Dear students, in this small video, we'll discuss arrays, how array can be allocated at runtime, that is, dynamic allocation of memory to arrays. First of all, what is array? Array is considered as an ADT, stands for abstract data type, because it also addresses implementation issues. The way in which you define arrays changes from one language to other language. Some language supports a array can have similar type of data, some can have different types of data. Whatever it may be. Array consists elements. Each of these elements can be referred with the index value. So that index is used to map the element. For example, if A is an array having some 5 data elements, we'll take the test of type integer. So that can be represented like this, having 5 different memory locations. This size depends on the data type, and that number of locations given to this element depends on the compiler. If a compiler uses 4-byte location, that means one integer 4 bytes here, another 4 bytes here, another 4 bytes here, another 4 bytes here, another 4 bytes here. For the time being, you just forget this one. I will indicate the first element with the index value. This is called the index. That number is used to refer the element. The index of the second element is 1, this is 2, and this is 3, and this is 4. The element will take that as 10, 20, 30, and 40. The last element is 50. Here, the index is used to refer the element. Array index is mapped to the element. So I can write like this. The one column is used to have the index value 0, 1, 2, 3, and 4. So 0 is used to map the first element. 1 is used to refer the second element, and so on. This is the third element, this is the fourth element, and the last one is the fifth element. Which is that first element in this diagram? 10, 20, 30, and 40. That's what this sentence is. Array index used for mapping the element. Using index, you can refer the elements of that array. So, I'll erase these things. You take any array. For example, A is an array. This has got 2 elements. One is the index, other one is the value. So that can be referred like that can be written like this. A, the fifth index of that element is 10. In C, this can be written like this. A of 5 is equal to 10. Whatever may be, well, that index value is an infinite order set of one dimension. In this example, I gave one dimension. In C, that can be written like this. A of 5. The dimension of this A is 1. Size of that dimension is 5. If I take an array of B having 2 dimensions, in C, that is written like this with the 2 square bracket. Here, the maximum index is given, that we take 5 as number of rows and 5 as number of columns. This can be written like this, drawn like this, having 5 rows, 1, 2, 3, 4, and 5. The first column, second column, third column, and fourth column, the last column. These are all the row numbers 0, 1, 2, 3, and 4. Column values are 0, 1, 2, 3, and 4. Here, array is arranged in the form of matrix having 5 rows and 5 columns. Suppose to access this element, I need to give two values. One, the row value, other one is a column value. If this matrix name is A, if this two-dimensional array name is A, this can be referred or accessed like this A of 2, and the column is also 2. A of 2 comma 2 is used to refer that row and column. There are three different functions that can be used to perform various operations. The first one is creation, the second one is retrieve operation, and the third one is store. The first one is array creation. This function returns an array of j dimensions where list is j tuple whose ith element is the size of I dimension. Items are defined. In C that can be defined like this int a of 10. This is the creation process. The elements I don't know, undefined. And the size of that array element is 10. 10 elements are accommodated starting with the value and that name is given as A. A is having 10 elements. That's the creation. The second function is we are going to retrieve the element from A. Which element you are going to return? Retrieve that ith element. For example, if array is of size 10 and fifth element of that array is say 10, after the retrieve operation, you'll be retrieving this element. That is why return value is item. So whatever may be that index, that index value is that value. That 5 is the index. Suppose array size is 10 and you are forcibly retrieving 25th element. 25th element is not there in the array. So it gives the error message. Third is the store operation. I have to modify this 10 by 100, say, where? In the fifth place. That operation is stored. So, whereas you are modifying the element, something is changed in the array. That means you are going to return the modified array. So, three parameters are required in which array you are going to perform the operation store, that is array name, which place you are going to modify the element, that is I, what element you are going to store in that place, that is X. Like this in C can be written like this, A of 5 is equal to 100. Mathematically, this is written like this. The operation is called store. In C, it is assignment statement, store. Then, what is the array name? That is A. Index where you're going to copy, that is 5. What element you're going to copy, that is 100. So this is how that is written generally. This is particular to C. This is in general. Now, how static and dynamic array is created in C. The syntax goes like this. The first is the data type, second is the array name, and the size. In C, suppose A is an array of size 5 with the data type 5. So that is written like int A of 5. 5 is the size, A is array name, int is the data type. Different elements are indicated like this. A of 0, A of 1, A of 2, A of 3, and A of 4. Let us take these elements as 10, 20, 30, 40, 50, and 0, 1, 2, 3, 4 are the index value. Then what are these? Let me take the starting address of the array as 3000. If this compiler takes 4 bytes of data for one integer, the next value is 3004 because 3000, 3001, 3002, 3003 for the first element, 3004, 5, 6, 7 for the second element, 8, 9, 10, 11 for the third element, 12, 13, 14, 15 for the fourth element, and 16, 17, 18, 19 for the last element. Then I need to access the fourth element. This element I need. What is the index? Index value is 3. The element is 40. Whose address is 3012? How to calculate that one? That means for accessing element, I have to start from the base address. So here in this case, it is a 3000. The formula is goes like this. You start from the base. You start from the base. Here base value is the address of the starting address of the array. That is 3000 plus from the base you start working, traversing. So how much you have to work? That means you have to skip these three elements. Three elements to be skipped. Three elements to be skipped. So what is the number? That is I element you have to skip in general. Then how many bytes taken by the system to store each and every element? That is 4. In general, it is size. So the formula is base plus I value, that is index value, into size. 3000 plus 12, that is 3012. So you'll get the address of that using this formula. In C, the pointer is declared like this. The data type of the pointer which holds address of some other element. That element is of type integer as a meaning. Int star list means list holds the address of integer. List is a pointer name, pointer variable name, int is a data type, and star indicates that is pointer. So, memory allocation, how that is done for 1D and 2D. This is a pointer which holds the address of a integer variable. Pointer name is list. Now, memory allocation, that memory can hold anything. It can be integer, character, float, double, like that. But in that allocated memory location should be ready to hold the integer. For that, data type conversion is required. I'm going to make use of this memory location to hold integer. So int star malloc. How much memory location I need? If there are 10 elements to be stored, then the size of those 10 size of integer. If you know, you can put it. Otherwise, we just leave the task to the compiler to decide it. Size of integer, how many elements that you want to allocate? 10 elements. That means if the size of the integer is 4, number of data bytes to be accommodated to be allocated is 10. 4 into 10 is the answer. That is why you won't take too much risk. Give the task to the compiler. Same way, in case of dimension, two dimension, how it is possible? In the dimension, you have to add it. 3 cross 3, 3 into 3, or the row into column that you have to add it. We'll take a simple example how C uses static and dynamic declaration. I'm going to use 5 memory locations. If you are allocating the memory, use stdlib. Here it is not required. This is my array. The size of the array is known before the execution. That is why it is called static array. Array type is integer. Array name is a. Size is 5, 12, 23, 34, 45, 56 are the data. I'm going to iterate it. I don't want this value. I have to modify it. I can modify using scanf. I can override that previous value. User is going to read the data. Those values are stored here. Same way, you can access it also. That's about static declaration. We'll go for the dynamic. My array name, now my pointer name is list, which holds starting address of integer data item. So int list. How much memory location is required? That is the size of integer, number of elements, that is max. Use MLOF function or CLOF function to allocate the memory. Then, as usual, read the data and print it. Just note that my array name is list and it is a pointer, so ampersand is required because itself is the address. Then, like in the previous case in static, where you use the square bracket, you can use plus size, list plus I. That means how much memory location to skip from the base. Base address is list, how much you have to skip. Actually, the formula is base plus I into size. Here, that size is automatically multiplied during the execution. User need not worry. Then, in that memory location, how to access the data from that memory location, how to access the data. As the list is pointer, use star to access the data. So star of list plus I. In case of two dimension, one change, that is we are going to use row and column as the value. So you have to iterate two times. One to all the rows, then each column in that row. That is why in this kind of arrangement is row major. First you will be filling one row, then you will be going for the next row. After filling all the columns in that row, then you will go for the second row, like that. That is row major form. In case of column major, first you will be filling all the rows in that column. If that is done, then you go for the second column, like that. So that is column major form. This is row major order. So instead of one index, use two index. A of I comma j. As it is static, use ampersand. As it is static, no need of ampersand. Small changes here. If number of rows, number of columns is 4, this much memory allocation you have to do. As it's integer, size of integer is required. Then you start reading the data. So base address is list. How much columns you have to skip? That is I. That many number of columns. Then it will go to the next row, required row. This is for the row major. Column major little different. So with this, I'll be ending small session of arrays. Thank you.